Hello, this is the 5th video of the Linear Programming 2 series on the simplex method and integer programming for OCR Discrete Further Mathematics, and we will be interpreting the simplex tableau in greater detail. In the previous video, we saw how to perform the iterations for the simplex algorithm. We will now look at what the algorithm does graphically to give you a greater depth of understanding. You will remember that the initial tableau represented the information of these four equations from the augmented form of a linear programming problem. What we call the basic variables in this case are P, S1, S2 and S3. You can tell that they are the basic variables from the table because they are the ones where we have a 1 and then the rest of the elements being 0 in the columns. The non-basic variables have other values in the columns, and in this case are x and y. Now initially the simplex method is starting from the point 0, 0. And if we were to put the values x equals 0 and y equals 0 into those equations, we would find that p equals 0, s1 equals 12, s2 equals 30, and s3 equals 20. In other words, the basic variables take these right-hand side values. Worth pointing out that at the beginning the objective function is that p equals 0. Remember that steps 1 and 2 of the simplex method identified the x column as the pivot column, and then the element shaded darker as the pivot element. Choosing to pivot on the x column means we are moving from the origin initially in an increasing x direction. So in other words, along the x-axis or the line y equals 0 until we hit this first next vertex of a feasible region. You can see on the graph that this is 10, 0, and this is where the green line 2x plus y plus s3 equals 20 intersects with y equals 0. You may remember that at that point both y equals 0 and s3 equals 0. So at the end of the first iteration we are at this point here, and we will look to see the basic variables again. Well, in this case we've got p as a basic variable and also x, and we still have s1 and s2. Note that here, as we said before, the y and the s3 both equals 0, so they're non-basic variables at this stage. P equals 100. We can see that x equals 10, both from the graph and from the tableau. S1 will equal 2, and S2 will equal 10. So we can interpret from the tableau by looking at those columns which are the basic variables and their values from this right hand side, and also which at a particular point are the non-basic variables and set to 0. You may also remember that at the start of the second iteration we chose to pivot on the y column, and that will mean that we will then be moving along up to the point 8,4. And where the intersection of the red and the green lines are. So at that point 8,4, you can see that y will have increased to 4 and x will have decreased from 10 to 8. We know that this is where these two lines intersect, and we know that in this case S1 and S3 equals 0. Let's see if that's reflected in the tableau. The basic variables will be p and x and now y. We can see that S1 is no longer basic and that S3 are no longer basic, so that does accord with what we're expecting. And S2 is still a basic variable. Let's look at the values. We can see that p is 116. This is risen from 100, which we would expect because the algorithm is searching for the optimal value, so p should increase with each iteration. X is 8, as can be seen here, and y is 4, which is what we're expecting graphically. S2 will equal this other value of 2. So we can read all of that information from that tableau. It is important that you are able to interpret the tableaus at any stage within the simplex algorithm process. Remember that as there were no more negative cells in that top objective function row, step 5 of the algorithm now tells us we have found the optimum solution, and this will then be that p-value. It's worth thinking through what would have happened if we had chosen to pivot off the y column in the first iteration. If we had done that, we would have gone from 0, 0 in the increasing y direction to this point. That would have been the first iteration. And then we would have gone down to this point 6, 6 as the second iteration. And then we would have needed a third iteration to reach this optimal point. The simplex method therefore still works even if you do not choose the most efficient column to pivot off in the first place. It simply will take longer or more iterations to get to the optimal solution. So the method can be applied by hand to solve problems with more than 2 variables. And each iteration gives a valid solution, but it might not be quite optimal. Sometimes requires several iterations to get to the optimal solution, and we can see that choosing the pivot column will speed things up. You know you've got the optimal solution where there are no negative cells left in that objective row. And it is important to be able to interpret the tableaus at the end of any iteration. In the next video, we will look at a three-dimensional example of using the simplex method to consolidate your understanding.